Welcome to Unit 1, Lesson 4. In this, lesson, hopefully, by the end of it, I will be able to recognize when a quadratic function will have a complex solution. And you probably don't know what that means yet, but we're working on that. And something to think about is, what is I, and is it related to the quadratic formula? All right, so I want you to be thinking about these things as we go through the lesson. And there's a little math joke there at the bottom. Hopefully you understand it, or if you don't, by the end of the lesson you will. All right, so take a minute and pause the video, and we'll get going. All right, first thing I'd like you to do is think about it. Consider the quadratic equations and their graphs below. So we have f of x equals x squared minus 2x minus 3. I have f of x equals x squared minus 6x plus 9, and f of x equals x squared plus 3x plus 3. All right, so there are three different graphs of three different equations. All right. Think about it. Is it a mathematical fact that a quadratic function has two solutions? Right? Because when we've been solving quadratics, usually we get two solutions. How is it possible that a function like number 2 shows only one solution and function number 3 shows no solutions? What? Think about it. All right? So I want you to pause the video and write all this down and draw it and think about it. Because, in a little bit, you'll be able to answer this question. All right? So take a second, pause the video, and think about it. All right, we're going to start here by getting warmed up, and we're going to solve this quadratic for when f of x equals 0, this function for when f of x equals 0. And in order to do that, we need to use the quadratic formula, guys. All right? So hopefully remember that. We've devoted this formula to memory. I'm going to write it up here again just in case. I need you, though, to memorize this formula, all right? So it's negative b plus or minus the square root of b squared minus 4ac all over 2a, and that's x equals, right? So what we're going to do now is we're going to plug in to that quadratic formula. We have a, b, and c. So let's state what a is. I mean, I'm hoping that I don't have to do this at this point, but we're going to do it anyways. So a is going to equal 1 because it's a coefficient that goes with the x squared term. B is equal to 2, and c is equal to 4. All right? So let's plug these values in and see what we get. That's a negative 2 plus or minus the square root of b squared, so that's 2 squared, minus 4 times, it was b squared minus 4a, which is 1 times 4, which is c, all over 2 times 1. Okay, and that's x equals all that, right? So x is going to equal a negative 2 plus or minus the square root of 4 minus 16 all over 2. So that's x equals a negative 2 plus or minus the square root of, well, 4 minus 16 is negative, whoa, what's that? Did I just say negative? I sure did. Negative 12 all over 2. All right? Now, hopefully remember how to reduce radicals, okay? I'm going to take an extra step this time for you so that you can see it. So this is 4 times a negative 3 all over 2. So I can pull out that 4. So I get x equals a negative 2 plus or minus 2 square root negative 3 all over 2. So that means I can take a 2 out of everything. So I have x equals a negative 1 plus or minus square root negative 3. Whoa. Okay. So I get down here and I think to myself, what do I do? What do I do? I have a negative 3 under the radical. What's up with that? Well, what we're going to learn about today is I, okay? And I is the square root of negative 1. So I, let's write this on the side here, okay? I want this in your notes now. Don't forget everything I put in here and everything I put out goes in your notes, except for that comic strip, right? That doesn't go in there, right? So I equals the square root of negative 1, all right? So we don't actually leave the negative under the radical. We always represent the negative as I. So, and I pull that I out, what I have is a negative 1 plus or minus I root 3, all right? Pull that negative out because it's really what we have going on here. Let me put it on the side here. Let me put it up here for you. What I have going on is this is equal to square root negative 1, right, times square root 3. Or hold on, let's go back a step. It's equal to square root negative 1 times 3, which is square root negative 1 times square root 3, okay, which is what gives us our negative 1 plus or minus I root 3, okay? So that's what I is. It actually, complex numbers come in a different form, usually. And they have this form always, almost, well, they always have this form. It's just a matter of what A and B are. So the form for a complex number is this. So our form for a complex number, squeeze it in there, is A plus BI. A is called the real part, so A equals the real part. So that's the real number slash real part. Okay, and then we have B. Let's write that in a different color so we can see it better. Okay, I'm going to erase this part right here, the green here, okay? I'm going to erase that really quick so I can put those notes in there, okay? Hopefully you got that. So B is equal to the complex part slash number, all right? They always come in that form, A plus BI. All right, where A is the real part and B is called the complex part. Another name for I is not just complex number, but imaginary. So we're talking about imaginary numbers, we're talking about complex numbers. So imaginary numbers are equal to complex numbers. All right, so imaginary numbers are complex numbers. So you should be asking yourself, do I have two solutions here? The answer is yes, I do have two solutions. They're just not real solutions. They're imaginary or complex solutions, all right? So now you can understand that little comic strip in the beginning where it says square root negative 1. Well, that's I, that's the imaginary number. All right, so nobody can see 8. No one can see square root negative 1 except 8 because it's his imaginary friend. They go together. All right? So that's a little bit there. So let's move on. And let's think about this again, all right? Think about it. Consider the quadratic equation again, all right? So how many solutions does number 2 have? You know, is that possible? Well, maybe. We'll see. It sure looks like it to me, right? I think it is, but we'll talk about that in a second. And number 3, we just shown that we do get a solution, right? It's just what? That's right, it's complex, it's imaginary, it's not real, all right? Whew. So, the quadratic formula, it gives us a ton of information, all right? A ton of information, and it's related to everything that we're doing right now, actually. When we talk about solutions, whether they're complex or real, or, yeah, well, it tells us a lot. So if I have a negative b over 2a, remember that was h, right? That's what that told us. Well, the stuff under the radical is called something special, all right? This stuff under the radical here, that's called the discriminant, all right? So b squared minus 4ac is called the discriminant. And this discriminant is going to tell us a lot of things about the nature of our roots. Those are our zeros. It's going to tell us what kind they are and how many of them I have, all right? Notice the quadratic formula has plus or minus. That's important. That means that all my solutions are going to have, well, almost all of them, right? Not all of them, but some of them, most of them, are going to have what we call a conjugate pair, okay? So let's start out and see what happens. Well, let's see if you can, well, we'll just do it together, all right? So I have b squared minus 4ac, all right? So what happens if b squared minus 4ac is greater than 0? So I have b squared minus 4ac is greater than 0. What is that going to do? Let's think about that for a second, okay? So b squared minus 4ac is greater than 0. That means all the stuff under this radical is going to be positive. I'm going to have a positive number, right? So I'm going to have some negative number, or minus some number over here, plus or minus the square root of a real number, right? A positive number under the radical is a real number, all over 2a. So how many solutions do I get, and what kind do I have? Well, since I have the plus or minus, remember that breaks into two parts, so I have two solutions. What kind of solutions are they? They're real. So I have two real solutions. So this means that I have two real solutions, or zeros, which are also called roots. Two real roots, all right? What happens when the discriminant is negative? B squared minus 4ac is less than 0. What does that give us? Well, we just did it, didn't we? We just did an example. Look back at the last slide. We had a negative number under the radical, right? So I have some number outside, plus or minus square root of a negative number all over 2 times some number, right? So that's going to give me a negative number, plus or minus I times the square root of whatever that number is, all over 2 times that number. So that's going to give me I, which is a complex or an imaginary, right? So rather than write all that stuff out again, we're just going to say this is going to give us 2 complex roots. Remember, though, that roots and zeros and solutions, they all go together, all right? 2 complex roots. And what's special about these roots? Something I want you to take note is that they're conjugate pairs. They're conjugate pairs. Okay, I want to see that in your notes. What does it mean to be a conjugate pair? That means if one root is a negative 1 plus 2i, the other one is going to be a negative 1 minus 2i. Remember, it was plus or minus? See that plus or minus right here? So they come in conjugate pairs, a positive and a negative. That's what that's called, all right? The number in the front always stays the same. And then what happens when b squared, there's only one other case, right? B squared minus 4ac equals 0. That means you have 0 under the radical, right? So let's put that down here. I'm going to write that down. So that means I have minus some number plus or minus 0 over 2 times a number, right? That's just a negative number, whatever that is, all over 2 times a number, right? So I get one solution, right? I get one answer. We call that's called one real double root. Okay? So things like f of x equals x minus 2 squared. All right? When we set that equal to 0 and we solve, right? If you set that equal to 0, I have 0 equals x minus 2 squared, right? I solve that out, I get that x equals 2. So 2 is one double root. You can multiply that out. If you multiply that out, that would be, if you saw things like f of x is going to equal x squared minus 4x plus 4. It factors into f of x equals parentheses x minus 2 squared, all right? So things that factor that way will have one double root, all right? And when you plug into the discriminant, you get 0. Okay? Oh, that's a lot of information, guys, to absorb and get down. So let's, hopefully you can pause this and get all these notes down and get that written down. And let's talk a little bit and do an example real quick, all right? We're going to do 2, and then you can move on to your homework. Well, this is your homework, right? With all this stuff, I better see this in your notes. I'll be handing out jugs. All right. Find the discriminant and state the number and types of solutions. So the discriminant was, or is, I should say, the discriminant is b squared minus 4ac. Okay? So, what is b here? B is negative 6. So that's a negative 6 squared minus 4 times 1 times 5. So that's 36 minus 20, which is 4. So what kind of solution am I going to get here? Am I greater than 0? Yes. So my discriminant is 4, and I'm greater than 0. So that means that I have 2 real roots. And let's just say that they're distinct. Do you know what that means? Distinct means different. They're 2 distinct roots that are different, all right? I want you guys pause this and take a stab at the next one really quick. Why don't you try it? All right, so we have a negative 12 squared minus 4 times 4 times 9. Let's not let the arithmetic get in the way. 12 times 12 is 144 minus 16 times 9, which is 144. So our answer is 0. Since I have 0 under the radical, right? That's the discriminant. That's the part that's under the radical. That means I have one real double root. Okay, that's a root that's repeated twice, right? Graphically, what does all this mean? Let's go back to our think about it question really quick. All right. Nope, went too far. All right, so this one is, the discriminant is b squared minus 4ac. So for this one, the discriminant is greater than 0. For function 2, that's b squared minus 4ac equals 0. And the last one is b squared minus 4ac is less than 0. Okay, that's what it means graphically, if you were trying to picture this, all right? So hopefully you got those, and I'd like you guys to try these problems out yourself. Okay, numbers 7 through 12, you should be able to knock those out really easily by applying the discriminant. Take a stab at it, guys, and enjoy. And then the challenging problems. I really want you to try these problems. If you don't try them, guys, I'm going to be incredibly disappointed. The thing you need to think about for this is our rules for the discriminant, all right? You have to use our rules for the discriminant. All right? You're going to apply the rules to each one of these cases. All right? If they want to think about it. All right? I'm not going to tell you exactly what to do, but I'm telling you, you need to use the rules of the discriminants and apply it to each case. Think about how to connect the rules to what they're asking, okay? It's not that hard. You can do it. I know you can. All right? I really want to see some effort here. And if you don't know what's up, then I expect to see you asking me this question, all right? And I will see you guys later. Have a good night.